Okay, so number 8 here says, they give you A and B. You can all see? Yeah? Okay, so they give you A and B. They say A is 4I minus 2J. And B is 7I plus 5J. And I say find T so that A plus TB is on the I only. So first we should find A plus, do you mind closing the door? Yeah. First we need to find A plus TB. So that would be 4I minus 2J plus T, 7I plus 5J. So that would be 4I minus 2J plus 7TI plus 5TJ, which is, leave me alone, which is, how many I's? 4 plus 7TI plus minus 2 plus 5TJ. That's what that equals. Now, this is the key step. I tell you that this is only on the I. It's only horizontal. So what does that mean about the J value? Yeah, that J piece must be 0 because I tell you it's only on I. There's no J. So that means that this piece here must be equal to 0. That means minus 2 plus 5t must be equal 0. So that means t must equal 2 over 5. I can put that in here now. So I get 4 plus 14 over 5i, which is 34 over 5i. What do they ask for? The t? Oh, okay. So it's a bit tricky. It's tricky for sure. For the exam, really, you only need to be able to do 1 to 6. But it's good if you can do the more difficult ones too, like number 8. But I only expect you to be able to do 1 to 6.
Yes, semester 1.
And semester 2.
So it is.
Huh?
You know, just say like
Semester 1 to just 1 to 6.
For this page?
Yes.
Oh yes, what I'm saying is, for the exam, for the topic about vectors, you only need to do questions as difficult as 1 to 6. You know? Yeah. But I think 17,
I did most of this thing do last year.
yeah, I'll do 17. Yeah, I'll do 17 because I can show you a way to do it from math class. So 17 now. I can go down? 1 sec. Yep. So in 17, I say 4i plus pj is perpendicular to p plus 1i minus 2j. So I say these two vectors are perpendicular. Now let me show you a very smart way to do it. How big is this piece here? 4. And how big is this piece here? P. How big is this piece here? P plus 1. And how big is this piece here? Minus 2. The slope of this line is P over 4. Now I don't actually think I stressed that in math class, But slope, I did say, if the slope is bigger, it means the line is steeper. And if the slope is 0, it's like this. So, in fact, slope is just the height divided by the base. That's the slope. So if I make it bigger, then it points higher. That's another meaning of slope. What's the slope of this line? Well, that would be minus 2 over p plus 1. So if I think of these as lines, there's the first line, and there's the second line. I know they're perpendicular, so what can I say about their slopes? That's a minus, sorry. What can I say about their slopes? They multiply, they should be minus 1. Do you remember that from maths? If they're perpendicular, it means this. So it means I can say p over 4 times 2 over p plus 1 should equal minus 1. So I have p over p plus 1 equals minus 2. So I get p equals minus 2p minus 2. So I get 3p equals minus 2, p equals minus 2 over 3. No.
I think it's because you associate minus in the 2...
Here.
Oh. Right there, sorry. Like right next to it.
Here?
Associate minus 2.
Oh, it is minus 2.
No, like in the actual equation, like it's p over 4 by minus 2.
Oh, I forgot this minus here. Sorry, so there's a minus here, basically, yes. There's a minus here, there's a minus here, so that instead should have been, oh yeah, that would be p equals minus 2. Yeah. Sorry, so those two, they're wrong there. I'll zoom out a bit for you. Here you go. Can you hand it back to Louise there? Thank you.
It's minus b over...
Yeah, sorry, this is a minus here.
Yeah, but...
Oh, here?
Yeah.
This is a minus.
Over 4, right?
Yeah. Or p over minus 4. It doesn't matter where you put the minus. Because if you look, just put the minus in front. It's easiest.
I'll try to use hand and it just didn't work out.
It was.
It was going to it was just really, wasn't it?
I don't think that's what they wanted, yeah. Question? No? Yes.
I used to be the boy.
Yes, I think maybe I know. What did you use?
Transfer the vectors into coordinates.
Yes?
And there's an equation for two vectors which are different.
Yes?
x1 times x2 plus y1 times
Yes.
y2 is 0.
Yes? Use that.
Yeah.
Get the right answer?
Yeah.
It's no problem. We won't do that in maths class though. Okay? Alright, can we go on to the next lesson then? Yeah? Okay. So we've done vectors and we've done units and dimensions. So these are the basic skills we need for physics. Basic skills, okay? So now we're going to have our first look at physics problems. So what we're going to start with...
Sorry.
Yeah.
You download picture on C++?
I will upload all the videos today. You have the first video is on Moodle. I gave you the link.
Yeah.
And I will upload the vectors and scalars today.
Okay.
It's just like no time yet. So I'll do them today and you can review them on the weekend then. Yeah. Okay. So, kinematics. This is studying the equations for how things move. It's their movement. So, firstly, one dimension. We will just look at problems that move in a straight line. So we have somebody who starts here, and then maybe they move to here. So that's what I mean by one dimension. So I have to give you some words. We have U, V, A, T, S. So U is the velocity, initial velocity, yeah, velocity at the start. So we say this person starts with U meters per second. And then V is the velocity at the end. So we say he finishes at V meters per second, maybe faster, maybe slower. A is acceleration. I haven't said what acceleration is yet, I will say it now. T, of course, is the time, we all know that. And S is the position, or displacement, yeah. So in other words, in my picture here, this is the S meters. And this is the origin, the starting point. And he is S meters from the start. So he starts with U, and he walks, and he finishes with V. He walks S meters, and it takes some time T to do this in seconds. So the unit here is meters per second, meters per second. This will be meters per second squared, seconds and meters. And I'll explain this word in a minute now. Okay. Can I start on? Yeah? Okay. So you all know this. You get on the bus, you get on the car. The bus stops at the bus stop. So what's its velocity? It's 0 meters per second. And then what happens? The bus starts moving. So its speed changed. Does the speed go up or down? Go up. And then you get off the bus then stops, so the speed goes down. That's what acceleration means. Acceleration means the change in the speed. So we can give the definition here. Acceleration is the rate of change of velocity. And if you want that as a formula, that is V minus U, because that's how much the change is. And as you said there, we'll go divided by T. So this is like the definition for A. It's the definition formula. Let's see what the dimension is for A. That's the dimension for velocity divided by dimension for T. So what's the dimension for velocity? That is what do we say? Length per time, wasn't it? Length per time, meters per second. Yeah. And then time is time. So this is length per time squared. In other words, the unit is meter per second squared, is the unit. Yep. Yeah. So, I go on? Yeah. So, just a quick example here. So let's say the bus starts at 0, and then 1 second later, it's going at 2 meters per second, and then another second later it's going at 4 meters per second, and then another second later it's going at 6 meters per second, and so on. So the bus is getting faster. How much faster is it getting? It's getting 2 meters per second faster each second. So this is what we mean when we say acceleration is 2 meters per second squared. It means every second it gets 2 meters per second more. of course, we can have it the other way. We can go 6 meters per second, 4 meters per second, 2 meters per second, 0 meters per second. And here we say it has acceleration of -2 meters per second squared. In other words, it's slowing down. It's getting slower. Yeah? Okay. Now that we have the language, we will now make some formulas. Okay. I can go down? One sec. So in total we have 4 formulas. Yep. 4 in total. Often we only use 3 though. Yes. Okay. I'm going to start on now. So, the first formula, it's not really a formula, I mean it's something that you would know from even maybe elementary school, that if I want to know the distance something has travelled, it's its speed multiply its time. I mean, you might even, like I said, you might even know that from elementary school. How's my battery? It's okay. Yeah, from the triangle. But there's a problem. Suppose the speed is changing. The speed is going up or the speed is going down. Then what number do we use? Do we use the speed at the start? Do we use the speed at the end? What do you think we might do?
Start.
Maybe the start, maybe the end. What do you think?
Average.
Or maybe the average. In fact, if the speed changes, we need to use the average. So we have the distance travelled is the average speed multiplied by time. Now remember, our man or whoever starts at U and then he finishes at V. What is the average of 2 numbers? Plus and divide 2. And what letter did we use for distance? S. So this is our first formula. I call it formula 0. Is distance travelled, and there's more to say about that, is U plus V over 2 multiplied time. So if you know the U and you know the V and you know the time, I can tell you the distance travelled. The first formula. Okay. Next formula? Yeah? Okay. Yeah, which one do you think I'm going to do next? Yeah, which one do you think I'll do next?
V equals U plus A.
V equals U plus AT. Yes, that's what I'm going to do next. But now, how to prove it? Well, I'm going to do is go back to the definition for A. What did I say A is? It's the change in the speed divided by the time. That means AT equals V minus U. So then V equals U plus AT. This is the next formula. If you know the speed at the start, and if you know the acceleration, and if you know the time, then you can work out the speed at the end.
So this formula for the speed is it?
Speed at the end.
Okay.
Yeah, the V. Okay, next what will I do? I'll do the S one.
Yes.
Yeah. Yes, yes.
This, if we need to find the speed, we use this.
Yeah, well don't worry. I'll do some examples about how to know which formula to use. First I'm just going to prove the formulas and then I'll show you how to use them. Okay. Next formula. In math class today you learned about the substitution technique. So what I'm going to do is, you see this formula here, it has a V in it. You see that? And then this here has a V in it. So I'm going to put V from 1 into 0. So I'm going to take this here and put it into that formula for V. So now I get S equals u plus v, which is u plus at, all over 2 times t. You see why I substitute, like we did in math class. So I get f equals 2u plus at all over 2 times t. So I get f equals 2u over 2 plus at over 2 times t. Well, they cancel. So I get f equals ut, I multiply the t now, plus a half at squared. And this is my next formula. You've seen the proof of these, Ugo, haven't you? Yeah. Yeah, you do the proof, I remember. Now I do applied maths in the evening too. I just don't know if your teacher always shows you proofs. You didn't see the proof in class? You just saw it yourself?
No, we did in physics. We didn't do applied maths. Like, we did.
Oh really? That's interesting.
Much later. Like, after the break on everything else, I was like, oh, this might happen. So we just learned it, but we already learned it in physics. So.
Yeah, it's not a very long proof.
You just have to make sure you explain what each one means. So.
Yeah. I'm probably some of you have seen these before. Have you seen the proof? The proof? Just the result. Yeah. It's good to see where things come from sometimes. Okay, so that's the second formula, well, the third formula. Now there's just one left to do. So for this last one, let me just remember, it's going to be here. If I go back just for a moment to this one here, I'll just rewrite this one as t equals v minus u over a. Do you see what I did? I swapped these two here. I swapped them. And now I'm going to put that in here for t, into 0, formula 0. Replace the t with this. So I'll do that down the bottom. I get now, replace t in 0. So I have f equals u plus v over 2 times t, which is v minus u over a. So I get f equals, here is 2a, u by v is uv, u by minus u is minus u squared, v by v is v squared, and v by u is uv. And what's great is that cancels that. So I have 2af equals minus u squared plus v squared. So I have v squared equals u squared plus 2af. And that's the final formula. This is formula 3. So we have 4 formulas. And I'll write them all together now. Now, well, I'll go to finish writing that. Yeah. Okay. So, just to be clear, u is velocity really, not speed, velocity. So what is the difference between velocity and speed? Louise, do you remember the difference between velocity and speed? Yeah, and speed. You remember the difference? It's okay if you don't. No? Abraham, do you remember the difference?
Velocity is a vector.
Velocity is a vector and speed is a scalar. Yeah? Now, what does that mean though? That means velocity could be plus or minus, but speed is only plus. Yeah? So if velocity is minus, what does that mean? It's going backwards. And if velocity is positive, it means it's going forwards. Okay? So the u and the v here are velocities. The a, what's the a? It's acceleration. If the a is positive, what's happening?
The speed's increasing.
It's getting faster. Yeah, and if the A is negative, it's getting slower. The S, now, the S I said is distance, but really it's position. What I mean by that is, if the S is positive 1 meter, it means it's 1 meter here. And if it's negative 1 meter, it means it's 1 meter behind me. So it's also plus or minus. The only thing that really should be positive is time. You count time as positive. There's no minus sign for us, okay? So just be careful. I'll write that down as well. But UVAS, positive or negative. T should be positive. Okay? Right, so let's put the formulas together. Our first one was S equals U plus V over 2 times T. V equals U plus AT. S equals UT plus a half AT squared. And V squared equals U squared plus 2AS. And remember, U, V, A, and S. Louise, you asked me what does this mean in the maths book. This means any number, positive or negative. It means any number, positive or negative.
Okay.
This is called real number. So if you write this, you're saying U, V, A, T, S are real numbers. They're positive or negative.
Every number.
Could be any number, yeah. But T should be positive. Okay, so here's our 4 formulas. Whoops. And just note this. How's my battery hanging in there? I ordered a new battery last night. All I can say is thank goodness for Hong Kong. The stuff is so cheap in Hong Kong. I got the battery on eBay. You know eBay, don't you? Yeah. And I got a battery, and how much do you think the battery was for a laptop, including the post? Oh no, just the battery. No. Just the battery. 60 euros.
13.
What did you think? 13 or 30? 13. Oh, not that cheap. That would be too good. I got the new battery for 25 euros. That was good. Because if you go to a shop here, it probably would be 60 euros to replace it.
Including post.
That's everything, total price. Yeah.
Include a post?
Oh yes. It's good, isn't it? Yeah. And then when I was also on eBay, I thought I'd order some headphones. Wireless headphones, you know? No wire. Yeah. Bluetooth. Yeah. It's only like 12 euros.
It's free.
Why not? Yeah, it's included in the price. It's good, yeah?
It's very good.
I know some website is the name AliExpress.
AliExpress, I know this one. It's the big Chinese one, isn't it? Alibaba, isn't it?
AliExpress.
AliExpress?
Yeah.
I thought it was Alibaba.
Another thing is cheaper and free shipping.
Free shipping? Good. Well, I think Alibaba, I think Alibaba they only do big orders for shops, I think.
That you can buy a few ones.
You can just, any amount?
Yeah.
Zero and buy some dishes.
Yeah.
Just buy you and then include the post.
Alibaba or eBay?
eBay.
eBay. Yeah, eBay's good. Yeah. No, oh dear, now get my battery plugged in. Okay, so as we were saying, Saeed, how do we use these formulas? So we'll do some examples now, okay? So I'll just do number 1 on the worksheet. So can you all read question, I haven't given it to you yet, question 1. Oh yeah, there's something else to tell you just before I start that, but it's not so difficult to say. Okay, so we have just one thing as well before I do some examples. Something called a velocity time graph. So this graph really is not difficult, I promise you. You just put time here, and what unit do we use for time? Seconds. And here we put velocity, and what unit do we use for velocity? Meters per second. So let me show you this graph. Let's take an example of the bus. Okay, so you get on the bus. What's its velocity at the start when the time is zero? Zero. And then what happens as the time goes by? It speeds up. So it gets faster and faster. Does it keep getting faster? No, what will happen? Yeah, then it will be constant, as you said. It reaches its maximum. So the bus is travelling along, same speed, and then the bus driver sees someone at the bus stop, and then what happens? Slows down, slow, and then stop. And then he's waiting at the bus stop, 0, 0, 0, 0. People get on, and then what happens? Goes back up again. And then a person runs in front of the bus, bus stops. Alright? So this is just called a velocity time graph. It's where you put velocity on the y and time on the x. So, it's easy to draw. I mean, this number here is the maximum speed of the bus. Maybe like 20 meters per second, if it's in the city centre or something. And that's all. And maybe this here, 5 seconds. Maybe this is 10 seconds. This could be 15, 20, 25, or whatever, something like this. So, I mean, all I want for this lesson is a rough picture, just roughly like what I did. Okay? So, let's have a look at the first one. A car accelerates from rest, so that means it's not moving, to 10 meters per second in 5 seconds. Let's draw that. Can I go down? Yeah. So what happens here? The car starts at rest at 0, and then what happens? It goes up to what speed? 10 meters per second. How long does it take? 5 seconds. So that's the graph. Pretty easy, right? Now the real question is, they now want to know what is the acceleration and what is the distance. So the way we do this is we write down what we do know. Do we know the u? Do we know the speed at the start? Yeah. We do. What is it? 0. Do we know the speed at the end? Yeah, what is it?
10 meters.
Yes, 10. Do we know the a? No. Do we know the t?
Yeah,
what is it? 5. And do we know the x? No, we don't. So far it's okay, right? Now, I won't write them again to save time. You have the formulas in your notebook, right? So we know u, v, and t. Yes? Yes, we know u, v, and t, don't we?
Yeah.
So, let's go with the first formula. In the first formula, what letters do they use? U, V, and T. Don't they? In the first one I gave you. Can you use the first formula? Yes, because it has U, V, and T in it. Now look at the next formula. Does the next formula have U, V, and T in it? No. What's it missing? Or does it? Oh, it does. Yeah, it has U, V, and T. Yeah. The next formula, does it have U, V, and T in it? Well, it has U, it has T, but it doesn't have V. And now look at the last formula. Does it have U, V, T? No. So there's only 2 formulas I can use that have U, V, and T in it. Which 2? The first 2. So let's use the first one. F equals U plus V over 2 multiply T. That is 0 plus 10 over 2 times 5. So that is 25 meters. So that's how far the car moves. It moved 25 meters. Okay, let's use the next formula. What was the next one? V equals U plus AT. So that would be 0 plus, oh, I don't know the A. Oh, sorry, sorry, so I have 10 equals 0 plus A 5. So I get A equals 2. So I found the distance and I found the acceleration. So what I'll do is I'll let you try number 2 and then I'll do it. So when you write that down, when you're finished, do number 2 for me. Okay, how are we doing on number 2? It's okay, yeah. So what do we know in number 2? We know A and the speed. So we know U, V, and A. Yeah. So let's have a look at that one. Do you have that finished, Saeed?
No.
No, okay. I'll give you another minute. You have that one finished, yeah? Okay. So I should tell you, so you're clear, everything on this page you do need for the exam. Okay, so everything on this page you do need it for the exam. Okay, if you're still working on it, that's okay. I'll do it on the board if you want to look. So I have U, V, A, T, F. The question says it starts from rest and accelerates to 24 meters per second, and the acceleration is 3 meters per second squared. We don't know the time, we don't know F. So, let me think. The formulas I can use have U, V, and A in it. I can use V equals U plus AT, because that has U, V, and A. No, and V squared equals U squared plus 2AF. I can only use these ones because these are the only ones that have UVA and UVA in them. So, yes?
So the speed is not 24?
It is, yeah. But that's the speed at the end. Because the question, the key word here, do you have a highlighter? Give me a highlighter. You see here where it says from rest, that means at the start it's 0. And then it accelerates to 24. So these two words together mean it starts at rest and then it gets faster and faster to 24.
So this is before beginning.
That's at the end.
At the end.
Yes, and this is the beginning.
Okay.
Yeah. So that's why it's like 0 and 24 like that.
Okay.
Yeah. From rest is an important word in physics. I think maybe you use rest as a verb. Yeah. What does rest as a verb mean? To relax, to sleep. Yes. To stop. Yeah. But in physics, from rest means it begins at 0 speed. Okay. Right. So let me use this one first. So I have V equals U plus A T. So T equals 8. 8 seconds. And let me use this one now. V squared equals U squared plus 2A 6S. So S is 24 squared divided by 6. What's that, please? 96, is it? So here is 96 meters. Yes, it is. Yeah? Okay, I'll give you one to try with my own example. Can I go down? Okay, let me see. Once I give you something tricky
This
now.
formula I need to remember in the exam to show the formula.
Oh, they give you the formula in the exam, but it's so important and you do it so much you will remember it. Yeah, it's right, isn't it? Because he did this before and he will tell you that you think you need to check it in the formula book in the exam, you don't, because we do so many of these. No, you'll never.
Oh, never. Okay.
When you're 100 years old, you'll still remember them, yeah? You did physics before, so these are in your brain now, they won't leave you, right? Okay, let's do an example now, another one, if I go down. I want to find something a bit more difficult maybe. Which one? Oh no, we don't ever need to. I know the ones you're talking about. We don't worry about those ones for the motion. I know the ones you're talking about. Okay, let's see. I'd like you to do. Yeah, I want you to do one where it's slowing down. So let's say, for example, yeah, we have our car. And let's say it's going at, sorry, that's the front and that's the back. It's going this way at, let's say, 40 meters per second. But then the car has to put the foot on the brake to slow down. The car wants to stop, so then later it stops. So here is 0 meters per second, okay? And when you look at the distance on the ground, I don't know, let's say it's 100 meters. You can use this information to tell me, what I'd like to know is the acceleration. Now, before you started, should this number be positive or negative, the A? Why? Slowing down. So I would like you to find the A and the T, please. So I want everybody to do this for me. Give me the A and the T. Okay, let me just write down which formulas we'll need to use. So we have here UVS. So UVS, so I could use S equals U plus V over 2T. I can use V squared equals U squared plus 2AS. Okay, so I shall use this one first. S equals U plus V over 2 multiply T. So this means 100 equals 20t, so t equals 5 seconds. Now I'll use this one now. V squared equals u squared plus 2as, 200s, because it's 2 and an s is 100. So that means minus 40 squared equals 200s. Sorry, yeah, I always do that. Minus 1600 over 200, that's the A. Well, that's kind of nice. That means it's minus 80. Oh, sorry, I left the 0 on the top. Minus 8 meters per second squared. Yeah. So the A here is minus 8 meters per second squared. So, use the ATS. How many variables do you need to know to solve these problems? Well, you must always know at least 3. You can't do it if you only know 2. You have to have 3 at least. If you have 3, then you can find the 4th and the 5th letter, no problem. Okay. Can I scroll down? Yes. So, Louise, do you remember now what is the difference between velocity and speed? Huh? Well, I'll show you a little trick here, look. Velocity starts with V, doesn't it? So it is a vector. And speed starts with S. It is a scalar. Yeah?
Wait on.
Huh?
Okay.
You got it?
Okay, I'm right.
Yeah. A equals minus 1, 600.
Where? Here, yeah?
Yeah, 600 over 200.
It was minus 1,600 over 200.
Okay.
Yeah. I'll pick on you again, Louise. Tell me, what is a vector?
Sorry?
What is a vector?
Vector.
Yeah.
Vector is velocity.
Yeah. But tell me, what is a vector? Like, explain to me, what does this word mean?
The vector is the
Direction and
length.
length. Yes, direction and length. And what's a scalar?
The scale is the scale.
Yeah.
And vector is the size.
Yes.
And the max.
Yeah, it's just the size, no direction. Yeah. So vector has direction and scalar has no direction. So here, that means you have plus or minus, but speed is plus. Okay. I just really want to make sure everybody's clear about that. So for example, let's say this man here, he walks this way at 10 meters per second. What's his speed? 10. What's his velocity? 10. Now let's say he walks backwards at 10 meters per second. What's his speed? 10. What's his velocity? Minus 10. Now that's really important, because in the formula you must have it correct. Okay? If you make a mistake here, you get the wrong answer. So you must have it correct. Alright. Now, I'll just remove the man again. Okay, so here's my man. He walks 100 meters and then he walks 10 meters. What is the distance he traveled? Well, he walked 110.
Yeah.
Yes, but S is 90. So I'm saying please be careful with this vocabulary, okay? S, I only care
From where it is.
from where he starts to where he ends. That's all I care with S. So that's what I mean by S's position. Well, I think I want to give you another word as well. Displacement. So displacement and distance. So displacement is a vector, but distance is a scalar. Distance is only positive, but displacement can be positive or negative. For example, if the man goes here, what's his S? His displacement S? It's minus 10. Oh dear, I'm making my pen smaller. What did I do? Oh, hang on. There we go, darker. Yeah. Oh, too dark. There, that's about right. Okay, so, quick check. Can I go down now? I'll go down. Alright. So we have speed, velocity, distance, displacement, acceleration, time. Okay, so first question for the class, vector or scalar? Speed, scalar. Velocity, vector. Distance, scalar. Displacement, vector. Acceleration, is a vector, because it's plus or minus. Time, scalar. Okay, now, UVATS, which letter do you think speed could be used for? Well, it tells you information about U or V. I mean, I have to tell you if the car is going forwards or backwards, if it's at the start or at the end, but it's used for U or V. Velocity? Yeah, it could be used for U or V. Distance? Could be S. Displacement? Could be S. Acceleration? Time? T. Which one of these needs more information? Well, speed, I need to tell you if the car is going forwards or backwards, so you know if it's plus or minus. What else needs more information?
Displacement.
No? Distance, yeah. Distance, yeah. Because you want to know if the car is 10 meters forward or 10 meters backwards from the start, or whatever. So there's lots of vocabulary here. But I hope the formulas are easy to use. I think the biggest difficulty, especially for people with weaker English, is just trying to get familiar with all of these words. Okay. Now I think we have, or are we over time? Oh, we're over time. My goodness. Do you have class at 4?
You don't have the math class.
Yes, not time.
Math class. What room?
I think it's still W2.
It was
D2.
W2?
Yeah, it was D2 on 3.
Back to